We have looked at why an SMS is important and discussed some key safety points. Let's move on to the SMS fundamentals and see what makes an SMS work. A safety management system is composed of only 4 components. We will briefly talk about each component now as an overview, and then go into much more depth shortly. The policy component defines top management's objectives and requirements. Policy provides the structure, procedures, and controls for SMS implementation and maintenance. Procedures and controls are essential safety attributes in the design of robust systems. The Safety Risk Management, SRM, and Safety Assurance components are the primary functional processes of the SMS. These 2 components combine system safety and quality management into an interactive process. SRM is where hazards are identified, analyzed for risk, assessed, and controlled. Safety assurance is where the controls are monitored to ensure they continue to work to mitigate safety risk. The safety promotion component provides the processes necessary to support a sound safety culture, such as communication and training. The safety culture of the organization is part of the environment that surrounds the entire safety management effort. Notice that policy sits atop both SRM and safety assurance. It sets the framework, the tone, processes, and procedures for the SMS. Policy is directed by management, but once established, the primary functional processes of an SMS are the SRM and safety assurance. Notice also that safety promotion is not limited by a box. Like a safety culture, it permeates all SMS components and the organization. We previously have seen the foundational components of an SMS and the relationship between the service provider's SMS and how it evolved from the ICAO requirements. Now we're going to look at the 2 main functional processes that apply to any safety management system. Remember, a safety management system provides a systematic way to control risks and provide assurance those risk controls are effective. In the decision-making process, there are 5 steps. During this part of the presentation, we will outline each of those 5 steps and demonstrate how they apply to the safety risk management and safety assurance processes, thus allowing us to better understand the systems and tasks involved. Step 1 is to gain a fundamental understanding of the problem, design, and context. Step 2 is to gather information about the system elements that are relevant to decisions to be made and actions to be taken, specific information. Step 3 is to analyze the data. This is a human activity used to make sense of the data, analysis. Step 4, assessment, is applying judgments based on the available data and the decision maker's experience. Is the situation acceptable or unacceptable? Assessment. Step 5 is where a decision is made, an action taken. Inaction, to do nothing, is sometimes an acceptable action. This may be the result of an assessment that the design, performance, or goal is attained. Action, problem, resolution. If you remember, the first of the 5 steps in the decision-making process is system and task analysis. System analysis is designed to provide the opportunity to gain specific information. This analysis needs only to be as extensive as required to understand the process in enough detail to develop procedures, design appropriate training curricula, identify hazards, and measure performance. The second step is to gather specific information. Here we play what if. What could go wrong with our processes under typical or abnormal operational conditions that can be considered hazardous? Step 3, analysis, facilitates the determination of the likelihood and the severity of the potential injury or damage and the resulting consequence if an event occurs. Step 4, risk assessment, is a decision step based on combined severity and likelihood. Is the risk acceptable? When potential severity is low, or likelihood is low or well controlled, we may be done and ready for operation. If the risk assessment determines the risk level is acceptable, it is then transferred to the safety assurance side of the workflow to to assure that the risk level does not change and remains acceptable. If the risk assessment determines the risk to be unacceptable, then a risk control must be designed to either eliminate or mitigate the risk to an acceptable level. This risk control is then processed back through the safety risk management system to determine if the design risk control actually has met those requirements of either eliminating the risk or mitigating it to an acceptable level. The design loop is continued until the risk is acceptable or until it is determined that the proposed operation cannot be allowed because the risk is too great. We now move to the safety assurance side of the workflow and step through the same 5 basic steps of a decision-making process while observing the system operation as it acquires data and uses the risk control processes that have been designed and documented. Monitoring and management of these documented processes is a critical part of safety assurance. In Step 2, data acquisition, needed data are gathered to test the controls. This data comes from a variety of sources, such as continuous monitoring, periodic audits, and employee reporting systems. In Step 3, the data acquired in Step 2 are used to analyze the system to ensure that it is operating in the manner in which it was designed. If performance is not as intended, the root causes of shortfalls can be determined, and new or unexpected results of system performance can be pinpointed. Step 4, the safety assessment process, in which decisions are made concerning the performance and effectiveness of risk controls, is sometimes called COS, Continuous Operational Safety. If the assessment process finds that the system has operated satisfactorily and either eliminated or mitigated the risk to an acceptable level, then the checking, analysis, and assessment loop, also known as the happy loop, is continued in the safety assurance part of the workflow to continuously monitor and affirm the system's performance. If an unexpected consequence has resulted from previous risk controls or actions, that result is transferred back into the safety risk management portion of the workflow to be processed again as a hazard, and the risk analysis with the risk mitigation process taking place to either eliminate or mitigate that new risk. If during the system assessment it is found that a corrective action is necessary, the process is continued to Step 5, where corrective actions are initiated and that information fed back into the safety assurance side of the workflow to ensure the corrective action has corrected the performance deficiency and has not introduced any unexpected consequences. Many times the corrective action is straightforward. As you can see, the safety risk management side of the workflow evaluates the design of the system, and the safety assurance side of the workflow evaluates the performance of that system. It is important to remember that the safety risk management and safety assurance workflows apply to any robust SMS. As a recap, the SRM process is essentially a design process where you understand the objectives, system, and environment of the operation in enough detail to identify the hazards and develop risk controls. The safety assurance process is a performance assurance process that monitors and measures risk controls to assure or gain confidence in the system's ability to maintain risk controls and ensure continuing operational safety costs. Together, SRM and SA are tools to be used in decision-making to manage risk, a safety management system. Now let's address the roles, responsibilities, and relationships between the FAA and our service providers. Dr. James Reason described the 2 principal functions within a business organization, production and protection. First, we have productive functions, the reason for the existence of the business, to provide a useful service or product at a profit to public users. The second is the protective function. We must balance these 2 functions. The management chain from the top through the managers who oversee operational functions have both sets of functional responsibilities. Production, the obligation of supplying products and services, and protection, the obligation to provide them safely. The FAA's contribution to public safety at this level is through the agency's oversight systems. Traditionally, this has been through surveillance. The FAA still intends to conduct surveillance, but its focus has changed to supporting safety assurance. This is an essential concept of system safety. The FAA Oversight Program, SAS, and MPG, and our internal SMS will provide the agency's safety assurance function. SAS, our current oversight system, adds a management system to oversight. These elements organize regulatory requirements into a systematic structure of systems, subsystems, and elements. SAS and the MPG organize the oversight system into two sets of modules: design assessments and performance assessments, PAs. At this point, we've gone as far as we can with oversight. Real safety management must involve processes from within the operator's organization. Thus, we add the operator's SMS, the external SMS, consisting primarily of the two functional processes of SRM, design, and SA, performance, that we discussed earlier. These are supported by the policy and promotional components of the SMS. SRM, a design function, will work closely in conjunction with the design assessment function of the oversight system, where certification and program approval acceptance decisions are made. Likewise, the operator's safety assurance functions and the FAA's performance assessment processes will work to assure or gain confidence in the continuing operational safety, COS, of operational systems. Finally, for this module, we reach the summary slide that wraps up the critical elements and functions of an SMS. They can be captured in two statements. SMS provides a systematic method to identify hazards and control associated risk, and provide assurance that risk controls remain effective. Now we will explore the key elements of the SMS policy component. All management systems must define policies and organizational structures. An SMS policy must show management's commitment to safety management for the entire organization and must define safety objectives for everyone in the company. And SMS policy must establish the framework necessary to meet those objectives. If top management does not lead the way into SMS, a safety management system will never be established. It'll be a dream. Without top management, safety management will never mature. Top management must show personal involvement, must establish safety goals and objectives, must provide the resources to build and maintain an SMS, and must clearly communicate that information throughout the organization. These are critical top management activities for the development of a healthy safety environment. ICAO terms SMS as the managerial approach to safety. This differs from the reactive approach that is characteristic of many safety efforts. As such, it goes beyond the fly it, break it, fix it, and forget it of previous safety models. Under an SMS, managers must manage safety. Safety management uses the same skills and knowledge and the same decision-making effort as financial management or human resource management. What are these management requirements? Part 11965 establishes management requirements. The sufficient qualified management have a regulated goal, and they have regulated duties to perform that are very general, non-specific duties. SMS provides a structured methodology to integrate those positions into the safety management system. What about the technical managers, the experts who manage the flight line, training, or hangar floor? What part do they play in SMS? They are some of the primary hazard identifiers. They are the primary risk assessors, decision makers. Is the risk acceptable? And they monitor controls to ensure their effectiveness. These managers are also responsible for safety promotion, communication, training, obtaining safety objectives, and many other critical roles. Previously, we determined that technical management identifies the hazard. The Director of Safety facilitates hazard identification by providing expertise, focusing the attention, defining hazard versus risk, etc. Management assesses risk and makes the decisions on acceptability. The DOS provides management the decision-making tools from analysis of the data. And finally, the Director of Safety assures the effectiveness of risk controls by monitoring the application of those controls. As you can see here, by signing the safety policy, top management is committing to an exhaustive list of expected items. It's expected that these items will have full management support. This leaves no doubt as to who owns the SMS. System documentation for SMS contains nothing new or different from other systems of the company. It conveys management expectations and work instructions to employees. Policy, procedures, instructions, outputs, documents, and records may be in a standalone manual or integrated into existing documentation or manual systems. There is no requirement for an SMS manual. However, it is important that an organization be able to manage safety. Often this is more easily done through a structured outline-style manual that classifies organizational-level SMS policies.